how's it going? So we're continuing with our paper. Okay, so this one is a very interesting paper, and right now we're just doing indices and all that stuff, so it's not very difficult right now. Okay, but then these are topics that you can really fail on, but they're pretty easy. So if you really listen carefully, sometimes it goes a long way, and then you tend to do better. Okay, if you haven't subscribed yet, we encourage you to subscribe and also like the video. It helps other people discover our channel. Okay, so we're continuing the first part, question 16a. It says evaluate 3 to the power 3 minus 3 to the power 0. So 3 to the power 3 minus 3 to the power 0. Here they just did it to confuse you. There's no division, there's nothing there. So these terms, they're actually fundamentally different terms. Okay, so you actually have to simplify them separately. So it's not a case of adding or subtracting indices. No, this one is quite different. You just have to do it separately. So another way to think of it is we'll be using what's called BOMDAS. Some say PEMDAS, some say BODMAS. It's still fine. They work out to give the same results. Okay, so you can say PEMDAS and then it's still fine. Okay, what this simply means is that simplify the brackets first and then do the orders. Orders simply means the powers. So the powers, we don't have any brackets here, we're supposed to do the powers. The powers would be 3 to the power 3, which is 27 here, and 3 to the power 0, any number to the power 0 other than 0, obviously, it's equal to 1. Okay, so 27 minus 1, then you get 28. Okay, so like this, it's still fine. And then the next part says simplify completely, and then you're given this. Okay, so what I advise you to do is to recognize that here, for example, this is a to the power 3, this is b to the power 3, so you can't actually find any square root here. So what we're going to do is we're going to preserve this to the power half, but then we're going to simplify inside there. So we have 9a to the power 3, b to the power 3. I'm just going to repeat this one, which I don't need to, so I'm actually not going to repeat this one. Okay, so I'm actually going to straight up just work it out. This one is a to the power 3, so this one is a to the power 5, so I can just create a to the power 3 at the bottom here, you see it. And then this one is b, so I'm going to create b to cancel with this one, so I can say b. I'm just doing this so that you can see, but then if you know how to do it directly, then obviously it saves you time and then you won't lose any marks there. It will still be fine. Okay, so 16, and then you have b, and then you have a to the power 5. On a to the power 5, we're going to create a to the power 3. And if we create a to the power 3, we are still left with a to the power 2. Okay, so what I did was I just changed the way that I present these variables here. Here, this was a to the power 5. I needed to create a to the power 3. So a to the power 3 times a to the power 2 here, you see, you'd still get the same thing. But then the reason I did it was so that we can be clear on what values cancel, what parts cancel. So for example, this one cancels this one, and also this one cancels this one. Okay, so what you'd get actually is 9b squared over 16 a to the power 2. Okay, like this. Then to the power half. If it's the power half like this, then you can take the square root. What it simply means is take the square root. So you can actually put square root, because to the power half simply means square root, so you can actually just directly put the square root here. Okay, so if the square root is there, that means that the square root of the numerator divided by the square root of the denominator. Okay, so for 9b squared, what it simply means is square root of 9, which is 3, square root of b squared, which is b, divided by square root of 16, which is 4, square root of a squared, which is a. So if they don't give you any, if they are mini marks, then you can just say plus or minus, it's still fine. But then like this one, I'm sure you get 4 marks. Okay, but then the square root of numbers, they usually come in pairs, so it would actually be plus or minus this. Okay, so that's one way to work it out. Another way to work it out would be to actually show how the indices work out. So it'd be 9a cubed here, so it'd be 9a, then 3, you can say 3 minus 5, since we have here. Okay, so divided by, when you're dividing the indices, when you're dividing powers here with the same base, then you can just subtract the indices. Okay, so times b here to the power 3 minus 1 for this one. Okay, so you can say divided by 16 is still fine. So here you get power half, then here you get obviously you get 9, then a to the power minus 2, then b to the power 2 here over 16. Okay, so to the power half all in all. So if you drop this one to the bottom, you'd still get this one would be b squared over 16, then this one would be a squared. Okay, so this one is another way to work it out, and then you'd still, this one would take you to this position here, and then you can proceed with what we did to distribute the square root sign. Okay, so square root sign for the numerator and for the denominator separately. So you'd still get the same answer. It's still plus or minus 3b over 4a. If you want, just 3b over 4a. I'm sure you get 4 marks. Okay, let's quickly move to the next part. Next part, what does it say? Next part we have this one. Okay, so okay, we have a square, and then it's joining this triangle here. Okay, so it's a pentagon. It's a pentagon in the sense that the outer layer, the outer shape, it's a pentagon in the sense that it has 5 sides. So you're dealing with 1, 2, 3, 4, 5. Okay, so this one, the size 1, 2, the size 3, 4, and this size, it's actually 5 sides. Okay, these sides, I was saying sides, I don't know why I was saying that, but then this one, they're sides. Okay, so you asked to calculate the perimeter, calculate the area of the pentagon. You want to calculate the area. So here you're supposed to know the side for the square part. Okay, so the side, let's say you want to know this one, let's say BC. Okay, so BC, you can even call it X, it would still be fine. If you want, you can use BC, it would still be fine. Okay, so here you should have a strategy for finding this. So you're dealing with the right angle triangle where you have 2 sides. So obviously you can find BC as the hypotenuse. Okay, so it would be BC squared, so is equal to BC squared is equal to 6 squared plus 7 squared here. Okay, and notice that BC squared is actually the area of the square here. Did you notice? Just because it's the side. Okay, so side times the same side, because the thing is all the sides, they are equal for our case. So you don't need to actually get the size of the side BC. You can just use BC squared because that's the area. Okay, so you can say initially you can say area equal to BC squared. Okay, so area of square here, you have to clarify that is the area of the square part only. So here you get 36 plus 49. Okay, so you can say 35 plus 50, so it'd be 85. Okay, so 85, you can say 9 plus 6, then you get 15, then 5, then you carry the 1, and then the 1 plus 3, then you get 4, then you get another 4, then you get 85. Okay, 85 square centimeters. Okay, now the area, we have to know also the area for the triangle. So triangle, you can even name it. It gives the examiner a sense of, oh, the student actually knows what he or she is doing. So you have this one here for the triangle. So triangle, the area is equal to half. Then the base you can take any of these two as the base. Okay, so this one can be the base because the other one is the perpendicular height to the other one. Okay, so it'd be 6, 7 here. So here would be 3 by 7 here. So you can actually get 21 square centimeters. Okay, so after getting 21 square centimeters here, you can say the total area. You can use this one. It's called sigma. It's a Greek letter. Okay, so it's useful sometimes when you just want to say sum of the area. Okay, So it's equal to 85 square centimeters plus 21 square centimeters. Okay, so here you get 106 square centimeters like this. This one would be your area. I want to show you a quick way to go about it. You can say area, then you say total, okay, equal to, because you want to save time. Then you say area of square plus area of triangle. Then we can even say triangle what? B, C, E, just to clarify. Okay, you can just say triangle. Then it's equal to area of square. Then you clarify that area of square is equal to BC squared. Then you say plus half. Then you say BE multiply by CE like this. Okay, so this shows that you really know what you're doing. Okay, then you say BC squared. BC squared you don't have, so you can say BC squared equal to BE squared plus EC squared like this. Then you say plus half BE CE like this. Okay, so after doing this, then you say BE squared. If you want, you can put because. This one, it means because. Okay, so this is just one presentation. So you can say because BC squared equal to BE squared plus C EC squared. Okay, even CE squared, it would have been fine since we're dealing with length. So this is it, and then here now you're just going to substitute and say BE squared, so it's 6 squared plus 7 squared, then plus half, then BE it's equal to 6, then CE is equal to 7, then you get 36 here plus 49 here, then plus 3 by 7 here, which is 21. Then you say 36 plus 49 plus 21. Okay, so here you can borrow, you can lend 1 here, so this one you get 50, then plus 35, then you get 85, then you get plus 20, then you get 105, then plus 1, then you get 106. Okay, so on this part you can actually just do whatever is comfortable for you, but I'm confident that you get the same answer. Okay, so this is it, and then you're done for this part. So thanks so much for watching. Make sure you like, share, and subscribe. Yuba out.